Hello, and a very warm welcome to everyone joining us for today's SelectScience webinar, Automated Cell Counting, Achieving Higher Throughput and Accuracy from Bench to the Cleanroom. My name is Dora Wells, and I'll be moderating today's presentation. I'm delighted to be joined by today's speaker, Tim Steppe, Application Specialist for Logos Biosystems. After the presentations, we'll move on to our question and answer session. Please feel free to ask any questions for the Q&A session at any time during the webinar. You can submit your question at the speech bubble icon to the left of your screen. And now, without further delay, I would like to hand over to Tim for today's presentation, and I would like to thank him for presenting to us today. Please go ahead.
Thank you, Dora. We are very grateful to you and the rest of the SelectScience team for your efforts with the webinar. We especially want to thank everyone in the audience today, and for those of you that may be viewing the recording of today's webinar at a later date. We welcome all of you and are greatly appreciative of your time and interest. My name is Tim Steppe, and I am the North American Application Specialist for Logos Biosystems. Logos Biosystems was founded in 2008 with the mission to develop powerful, advanced, yet easy-to-use imaging and analysis solutions for scientists. Our first product was the LUNA-FX7 Automated Cell Counter. Since that time, we have developed a portfolio that encompasses a breadth of imaging and analysis solutions that included systems such as the Quantum-TX Microbial Cell Counter, the Selena-TX High-Throughput Imaging System, and the X-Clarity Tissue Clearing System for in-depth 3D imaging. As we all know, biology happens at and across different size scales, and our product lines are actively designed with this fact in mind. So in essence, our goal is to help you see both the forest and the trees at the same time. Today, though, we are here to talk about our newest member of the LUNA Automated Cell Counting family, the LUNA-FX7, whereas you'll likely hear me refer to it as simply the FX7, and its applicability from the benchtop to the clean room. Cell counts are used in every phase of biotechnological activity. Accurate cell counts are needed for an expanding range of purposes. Applications such as determining concentration for passaging cells and culturing, or quantitating inputs for single-cell characterization applications like single-cell sequencing and single-cell phenotyping, and also including cell therapeutic dosing determinations. All these applications require accurate cell counts. With the growing number of applications requiring and needing cell counts, the need for not only greater throughput, but the ability to accurately count a broad diversity of cell and sample types has put an increased premium on finding the best cell counter for your purposes. Before we get into the nuts and bolts of the discussion today, though, we do want to pose a series of interrelated questions that start broad but narrow. At the end of the discussion, if we haven't convinced you that the LUNA-FX7 is a cell counter for you, we at least hope we can help you put a better framework around your search for the best cell counter for your needs. The first question is, why do you need cell counts, or what purpose will cell counts serve? No matter if you are in basic research, just starting a cell therapy development program, or optimizing a bioproduction scale-up, there are specific purposes for which you will use the data from cell counts. Cell counts may only serve one purpose for you, or they may need to be used for several. For example, if you are in an assay development group, you may need to establish protocols and standards for obtaining cell groups for all the different groups along the manufacturing chain. Cell counts that are performed may be used for determining inputs to assessing critical quality attributes, such as potency assays, or to assess optimization efforts in process development. Or perhaps maybe you are in a core facility and need to establish or confirm cell numbers and sample quality prior to performing a single cell characterization, such as sequencing or phenotypic determination. Single cell characterizations are a very, very powerful tool, but they are not inexpensive. If the provided cell sample is of poor quality, then both time and money are lost. Second question is, what are your requirements, or what features and abilities would you like the counter to have? Your purpose and working environment, perhaps even more so than sample type, will define the requirements for what features and abilities that you ideally would like the cell counter to possess. At a minimum, no matter your purpose or environment, you will want a counter that is accurate, precise, reliable, has a relevant detection range, and is hopefully easy to use. Let's face it, even though you may have to do cell counts, you want something that is going to be easy to use and not take up too much time. After all, this is the reason why you're buying an automated cell counter in the first place. Where needs can vary is based on group and environment revolve around several factors. What sort of throughput will suit your purposes? Will you be counting a few samples only a few times a week or many samples per day? What sort of data management needs will you have? What storage capacity will you need? What output and format for data reports will you need? Related to data management is networking. We need to integrate the counter into a network to be able to access or archive the stored data. Quality assurance and quality control. Will you need IQ/OQ for GMP or GLP? How often will you need to confirm the accuracy and function of the instrument? How will you confirm the accuracy of the instrument? Instrument variability. Will you need multiple instruments within a location and among different groups or across different sites? And what levels of variability are acceptable for your purposes? Finally, what, if any, regulatory requirements will you need to meet? Will you need to counter that is 21 CFR Part 11 compliant? Eventually, we do get to what type of samples are you counting, or what sort of challenges may your sample and cell types present for automated counting. We are very specifically referencing sample type, not necessarily cell type. The reason is we are seeing a greater demand to use more complex samples such as whole blood, cells with unique morphologies, and primary stem and specific cell types being isolated and expanded from dissociated tissues for therapy development and or single cell characterizations. But with increased complexity and diversity of cell and sample types comes increased difficulty in counting those samples and cell types accurately. For example, how much debris is in the samples? What level of autofluorescence is there? Does the morphology present challenges? And what degree of cell aggregation or clumping do your cells present? All these factors bear upon the counting method, protocol parameters, and what more than anything may influence the accuracy of the cell counts. No matter your environment, purpose, or cell type, we hope to demonstrate to you that the LUNA-FX7 can meet or at least be considered to help meet the needs you may have for an automated cell counter. So let's finally meet the LUNA-FX7. The LUNA-FX7 is a powerfully compact standalone instrument. Measures approximately 25 centimeters per side or 10 inches per side, depending on what you like to use for measurements. It has both bright field and dual fluorescent capabilities. With bright field, it may use trypan blue, erythrocin, bee stain, or methylene blue for yeast counting. In fluorescent mode, it uses acridine orange and propydium iodide, or as you'll hear us refer to it, AOPI, to distinguish live from dead cells and calculate the viability. From the outset of the design and release of our first counter, the LUNA Bright Field counter, ease of use and intuitive user interface has been a primary design priority for us. Students, techs, or whoever else are performing counts should, as much as possible, not have to put too much thought into operating a cell counter. You should be simple, easy, and intuitive. The FX7 is a fully automated cell counter. It does use slides, as we'll go over here next, but with a mechanical slide tray, you only need to insert a slide one time to count all or whatever slide chambers you want. It has both full autofocus and manual autofocus abilities. Protocol customization, even if needed, is simple and uncomplicated. It has an autosave feature such that it will automatically save the results of the count, images, and report, so that if your internal standards and practices require all cell counts to be saved, it does this quickly and easily. Controls may be operated via touchscreen or by a mouse plugged into the USB ports, or as I like to frame it, you have the choice of whether you want dirty fingers or gloves to touch the screen or the mouse. Depends on what you want to clean. Installation takes all of 2 minutes at most. Unbox and plug it in, and it's ready to go. Just to further emphasize its ease of use, is you simply plug in your cell or place your slide into the tray and press count. That's all that needs to be done. In addition to our traditional 2-chamber slide, we offer a single, a 3-chamber, and an 8-chamber slide. The 8-chamber slide is compatible with the use of a multi-channel pipetter, so to ease and greatly increase the amount of throughput that you can get through the use of the counter. Also on this counter, or also on this slide, you will notice that we have reference to fields of view. Traditionally, cell counters have analyzed a single image. Because of the automated nature of the FX7, this allows for multiple fields of view to be imaged and analyzed. The benefit of this, as we will see in a bit, is that this can greatly increase the precision, range, and accuracy of your counts. Quite simply, the more you count, the more accurate and reliable the results. I also refer to this ability as flexible throughput. And where the flexible throughput applies is in your ability to easily select slide formats and what chambers you would like to count. For example, if you're using an 8-chamber slide and you only have 4 samples, you can select the chambers you want to count, 1, 2, 3, 4. And after the count is finished, you can put the slide back into its pouch and use the other 4 chambers at a later time. The optimal dynamic range varies based upon the slide format, as you can imagine. Our 3 and 2 chamber slides have an optimal range of 1 × 10⁵ to roughly 2 × 10⁷ cells per mil. Based on cell concentration, we expect no more than a 3% CV for both intra and inter-instrument variability. So I mentioned earlier, part of obtaining accurate and reliable cell counts is to count a greater volume of cells. This can be accomplished a couple of different ways: analyzing a greater volume within a chamber or increasing the number of replicates that you count. By not being limited to analyzing only a single field of view, we can increase the volume per chamber that is analyzed. And with the different slide formats, you can easily count replicates. As we mentioned earlier, though, the complexity of sample and cell types that are being counted is increasing. While volume is an important component to accuracy, the ability of the instrument to accurately detect and delineate cells needs to be even greater. The test of accuracy comes from not only being able to routinely handle cells in simple cell cultures like hex cells, Rather, it comes from being able to accurately and reliably count more complex samples such as leukocytes from a whole blood draw, where the counter needs to be able to discern the less abundant nucleated cells from the anucleated cells like RBCs and platelets. Creating an autologous cell therapy like CAR T cell therapy, accurate information about the number and viability of the leukocytes, the initial draw, can provide some indication of the ultimate success of the downstream process. Further, as the CAR T cells are generated and ready for infusion, you want to be able to measure the efficiency of your processes, ensure you have enough cells for infusion. Given the inter-instrument variability we discussed, along with IQ and OQ and 21 CFR capability we will discuss here shortly, the FX7 is an instrument that can be used throughout the creation of CAR T or other cell therapies, no matter where the collection, manufacturing, and infusion may take place. How about clumpy cells? Most counters have struggled when it comes to clumpy or cells in aggregate. What the human eye may more readily discern present challenges for image-based cell counters. For example, this is a count performed with ASPC1 cells using a standard counting algorithm that is traditional throughout the industry. As you can see, they will typically struggle as cells cluster or even potentially overlap. The ability to deal with clumpy or cell aggregates was a major piece of feedback we received from customers. So we heard and we tried to respond. And we think we have vastly improved upon the ability of cell counters to deal with aggregated cells. Here we see the same sample of ASPC1 cells counted using the declustering algorithm used by the FX7, is where previously we see that algorithms may struggle to delineate accurately individual cells. You can see that now each of those cells is properly identified and counted. Here we have an even more complex sample that has not only cells that tend to aggregate, but also have debris remaining from tissue dissociation. And so we're increasingly seeing a number of tissue dissociations, primarily driven by single cell characterizations. And so oftentimes people will send us and say, what do we need to do here? How best to count this? And so the first thing we're going to say is, while the FX7 can handle tissue dissociated cells very well, you still need to do a decent job of the dissociation, because at some point the debris and things like that can interfere with the signal. But here's also the beautiful part about the FX7, and then because it provides you with such clear and crisp images, is it allows you to quality control your samples to see, okay, I need to do this aspect of my process better. And as we've mentioned multiple times, one of the major drivers we have seen has arisen from single cell applications, such as sequencing and phenotypic or functional characterizations. Not only are accurate numbers and sufficient viabilities required prior to using the cells or nuclei, but a certain amount of quality control is needed. So you don't want there to be too much debris, or if you're working with nuclei, as we see here in this lower right-hand picture, you need to make sure that the separation has been efficient. And while the FX7 was designed to be a mammalian cell counter, it can be used with non-mammalian cells such as yeast. Here we see the result from working with Saccharomyces and demonstrating the accuracy of the FX7 with counting cells along a dilution series over here on the left-hand side, and determining viability from standard heat kill experiments over here on the right-hand side. While the FX7 is a standalone instrument and doesn't need an additional PC for operation, it may be purchased with a standard 256 gig internal hard drive, or after discussion and exploration of your needs, it may also be purchased with a 1 or a 4 terabyte internal drive. It has both Wi-Fi and Ethernet capabilities and may be accessed through an SMB protocol through a Windows Explorer, allowing easy data backup and archiving. The data output consists of standard PDF report, raw and tagged TIFF images from each field of view. It also contains a CSV file that contains protocols that was used, total numbers, viabilities, so in other words, all the data, plus information that allows you to determine the results by each field of view should you wish. Ultimately, though, everything comes down to a matter of trust and confidence. Do you trust the data? Do you have confidence in the data? How can you trust the data? And why should you trust the data? To further bolster your trust and confidence in the instrument, we have developed validated pre-spotted slides for both bright field and fluorescent counting. These slides have the concentration, viabilities, and total cell numbers for you to easily see and to put into the instrument. Further, the QC slides, while they can be run independently, are designed to be run in the QC mode that is standard on all FX7s. You simply type in the product key and then count the slides according to whatever schedule is required by your internal practices. The FX7 will record each of the counts and allow you to set error limits. We will finish up today talking about compliance. And more specifically, we will go over an introduction to our CountWire system. The FX7 may be purchased with an IQ/OQ option and or preventative maintenance service. You will need to discuss with your local distributor about having both IQ/OQ performed and what is involved in the preventative maintenance plan. Further, the FX7 through the additional CountWire system can be under 21 CFR Part 11 compliance. One of the most frequently asked questions we get is, do I need to be 21 CFR Part 11 compliant? Or, in essence, do I need the CountWire system? Best answer that we can provide to you is the answer is up to you to determine. So we can give you some guidance. Are you in a GMP environment? How will the data the instrument generates be used? For what purpose will the cells or the final product be used? And most importantly, what are your own internal standards and practices? If you do determine that you need to run FX7 under 21 CFR, then we offer the CountWire system. CountWire system provides for all the prescribed regulations, including user access control, audit trail of all activities, electronic signature, and data safety and security. There are 3 components to the CountWire system. Obviously, there is the LUNA-FX7. Then there's the user interface software that gets put on one of your PCs. You do have to supply that PC. And then the CountWire data storage server. FX7s all come with CountWire capabilities. So in other words, this is not a separate app or piece of program that you have to purchase separately. The CountWire system, because it has different components, also may be purchased after an FX7. So in other words, if you are an R&D group and you're trying to develop assays or you're trying to develop your cell line, and you don't need to run anything under regulations at that particular time, that's good. But then as you find that, hey, this is working and we're going to expand out, we may need to buy other FX7s and we may need to put those onto the CountWire system, you can do that too. So this can be a post-fact purchase for the CountWire. The architecture and the data generated by the FX7 when in secure mode, which I'll describe in a bit, is contained on the data storage server. So in other words, data storage server has the guts of the system, or as you'll hear me refer to it, the DSS. The DSS has a 4 terabyte primary storage with another 4 terabytes of mirror storage for backup. It runs on with a Ubuntu operating system, and obviously it will either be, you can network it through Ethernet or Wi-Fi, and it is compatible with archival software, so that if it is required by your own business regulations that you need to back up data into your own secure data array, you can do that. Networking can be done through the Ethernet or Wi-Fi, as we mentioned. Although to speed up data transfer and interaction, we do recommend that the server and the counter be connected via Ethernet. Further, the DSS may be connected to multiple PCs and also multiple FX7s. So in other words, you can have an FX7 in the clean room, or you could have one in the QC room, or even one down in process development. And they can all be connected to the same data storage server. So you don't need individual data storage server for each individual PC. Once you've installed the client or the user interface software onto a PC, you will at that point need to log in to CountWire. So the first login is done by the administrator. And so there are 4 accounts: the administrator, and then there are 3 user accounts, which I'll go over a little bit more detailed here in a bit. So the user accounts are set up so that you can do sequential approval of reports. The administrator themselves handles such things as setting up password regulations, determining whether when a count is saved, whether it just saves the report or whether it saves all the images. They set up the user groups. They set up the approval chains. They also manage to create and edit the protocols and things like that that are not accessible to the users when they're running in secure mode. And so as we talked about, sign up is actually very easy. So the administrator will do the initial login, and then let's say that somebody named Jill Hill needs to log in and create an account and to become a user. So they simply click on sign up, go through the pop-ups and things like that. At that point, the administrator goes in, sets where they are as whether they're going to be at the top of the approval chain, in the middle, or even a creator, and also assigns them to a different group. So it's very, very simple and very, very straightforward. As we mentioned, the CountWire system allows for audit trails, and these are extremely important. And so through the administrator account, they can export these audit trails, and these audit trails track all activity from initial login of the administrator to the initial login of a user onto the FX7, and everything that is done on the FX7 are all recorded within this audit trail, or this event log. Just to go a little bit into what we mean between secure mode and non-secure mode. So the FX7 is designed to operate in 2 different phases. So you can do normal mode, and in normal mode, anybody can come in and use the FX7. So in other words, you could have somebody come in off the street and run a cell count if that's what they wanted to do it in user mode or in normal mode. So that's when the background screen is blue like that. However, once secure mode is turned on by the administrator in their account, an initial pop-up screen will come on. And then one of the users will need to go in and log in. And at that point, it starts running in what we call secure mode. And in secure mode, there are certain restrictions for what users are allowed to do. So certainly users will be able to perform counts. They will be able to select protocols, but they cannot change protocols. And on the other way, the administrator account themselves cannot log in or use the FX7. And so when it actually goes into secure mode and it's ready to be used, it goes from the blue highlights to the pink highlights. The user accounts are a different format. Since they are not the ones that are allowed to go in and change things or alter things within the larger kind of administrative realm, is what they will need to do is go in and to approve reports. So the other feature that FX7 has is report self-approval. So what this means is that if somebody performs a count, say an approver who's at the highest level of the approval chain goes in and performs a count, and self-approval is turned on, then they will not need to go in and then manually approve the report. It's automatically report. And so another question that we often get is, so when do we need to do this? Or, you know, what's allowed? And again, that goes back to your internal business rules. And so with that, we're going to end up by simply saying that we encourage rational skepticism. So in other words, don't believe us, believe your fellow researchers. One of the great things about SelectScience is their ability to aggregate the reviews and to give that information to you. And we will simply say this, and we encourage you to go see it for yourself, is that the LUNA cell counters are some of the most highly rated instruments within SelectScience. These reviews are based not on customer feedback, ease of use, after sale service, which is extremely important, and the value of money. And so our average rating is 4.8 out of 5.0. And this also applies to the FX7. Its rating is 4.8 out of 5.0. More importantly, though, is we encourage you to see it for yourself. So in other words, learn by doing. So we actively encourage for you to seek out and to set up a demo for the LUNA-FX7. Because ultimately, you need to be the one to determine whether this is going to be the counter that's good enough for your purposes. And so with that, we want to give a great big thank you to you all and to SelectScience, and we'll go ahead and take questions.
Great, thanks a lot for that interesting seminar, Tim. So now let's move on to the Q&A session. Now the first question I've got here for you, Tim, is how long does it take to perform a cell count?
Well, that's going to ultimately depend upon what slide format that you are using. So in essence, as you remember back, is that the FX7 counts a number of fields of view for each slide chamber. It takes approximately about 4 seconds to count a field of view. So if you're looking at a a chamber for a 2 or 3 chamber slide, that's going to be about 45 seconds per chamber, and certainly overall probably close to about 1:25 or so for the 2 chamber slide. And for the 8 chamber slide, since it only counts, say, 5 fields of view, it takes about a little over 2 minutes and 20 seconds to count that whole slide.
Great, thanks for that answer. The next question I've got here for you is the LUNA-FX7 able to detect green fluorescent protein and red fluorescent protein?
Yes, it can. But there is a caveat on that, is that certainly this is a cell counter. And so whether or not your cells are actually expressing those markers well enough for it to detect is another story. So certainly if you have, like, say, a transfection, or you have a really highly expressed GFP protein, yes, it will be able to detect that.
I see. Great. Thanks for clarifying that one. The next question I've got from an attendee here is, can multiple cell counters be connected with the CountWire software?
Yes, as we saw, so we have the ability to connect multiple FX7s to the CountWire system. So that could be 1, 2, 3, 4, 5, however you need to do. And that one CountWire system, or that one CountWire data server, can serve all those different cell counters.
Great, thanks for that. I've just got one final question for you here, and that someone is asking, how can I arrange a demo?
Well, first, thank you very much for your interest. We greatly appreciate that. And as we saw on one of the last slides, simply contact info@logosbiosystems.com, and then we will get you in touch with your local distributor to arrange a demonstration.
Great, fab. Thanks a lot for that. I'm afraid I'm going to have to wrap it up there. Thank you again to Tim for today's informative discussion and presentation. Thank you to everyone joining us online and for your interesting questions. I hope that you found this a worthwhile session. If you have any other questions, please feel free to email me at editor@selectscience.net, and I'll follow up with your questions for Tim. Now, remember, you can also download a certificate of attendance in the Related Resources tab to the left of your screen. And if you would like to listen again to today's webinar or invite a friend to listen, it will be available to watch on demand in a few days. Goodbye, and thank you once again for joining us.